Welcome to the Aerospace Ambition Podcast. I'm Marius, your host, and as an engineer, my passion lies in sustainable aviation and AI. In today's episode, we are talking about some of the projects for sustainable aviation with which Thales is involved. I'm delighted to welcome our guest, Chris Deseure. Since joining Thales in 2011, he has significantly shaped the design of critical embedded systems with a focus on crew alerting systems. In 2017, he joined the Strategic Innovation Management team of Thales AVS, where he led the launch of several disruptive projects, including the Thales Green Operations project in 2020. Currently, as Chief Product Owner, he oversees the development of Thales products and services for green operations, driving sustainability in their sector. Chris, bienvenue dans l'émission.
Hi.
Very nice to have you on the show, Chris. And first off, this is the first time that we host Thales. So I'm tempted to ask, what is the role of Thales in the context of sustainable aviation?
Well, thank you for the question, because that's a question we always have, because Thales is well known for its aeronautics activities, but also the defense activities we have, would it be in the air or on the ground. And for sure, we've been in the aerospace industry for decades now, but we asked ourselves what should be our place in the transition of aviation in terms of environmental concerns, climate concerns. And we asked ourselves this question a few years ago, and we are not aircraft manufacturers. We do not provide fuel. So we had these questions. And in fact, for sure, we are very present in the way aircraft are managed in the daily basis, especially in the operations phases with airlines, air traffic controllers. And our company is present in both both sides of the industry. We help airlines on a daily basis. We help air traffic controllers every day. And so we thought, okay, if we mix our two field of expertise, we should be able to do something.
All right. And maybe just to draw an image and make it very tangible, what could be some of the products or value propositions that Thales offers?
Well, based on the background we have, in fact, many aircraft today are equipped with flight management systems. So we have many pilots planning and executing trajectories with the help of our systems. There are dozens of countries also using our air traffic management systems, will it be to prepare the day to come, to know what are the flows of aircraft they will have to manage, but also to manage the safety of each flight coming across their sky. And based on that, you can figure that if you want to have efficient trajectories, it has to be efficient from the pilot and the airline point of view, but also from the air traffic control point of view, such that it will be efficient in terms of the energy that will be used, but also efficient from the airline perspective, and also efficient to be sure that it will be still safe, even if we try to reach the next level of flight efficiency.
All right. I think now everyone understands why I was so keen on hosting you. And maybe this should lead to the question about Thales Green Operations. So what is implied by those green operations? What does the term stand for?
We use this term because we really wonder how we can help all the actors that are currently engaged in aircraft operations to reduce the climate impact of the flight operations. So that's why we focus on operations. We say, okay, on a daily basis, how can we help all the stakeholders to put the sustainability concerns in their jobs so that it's easy to do it. It's not something we add in their jobs. That's not something difficult they will have to manage, in addition to all the rest of the very important things they have to do every day. And so that's why we focus on operations, and green is for how we can put all the sustainability concerns and the climate concerns in their daily concerns.
All right. I'm starting very early now with the podcast tradition of passing on a question from one guest to the next. And our previous guest was Michelle Bishop. And she asked the question to you, what is the progress on Thales tools to unlock green capacity in the airspace?
Well, that's a very, very good question, because to me, that's the main thing we want to introduce in our ecosystem, because we've been part of the flight efficiency concerns for many, many years. I mean, we did not wait for the past years to try to improve fuel efficiency of an airline. I mean, when you want to save money, you have to save fuel, and many actors have been playing on that for decades. But what we see now is if you want to get the next percent of fuel efficiency to reduce CO2 emissions, well, if you try to work on that all alone on your side as an airline, that will be very difficult, because there are many situations where what you try to do is not fully compatible with what air traffic control expected to do. And as they do not have the same plan at the exact same time, not always at least, that's very difficult to be sure that you will be able to convert what you had in mind as an airline or as a pilot to reduce the CO2 emissions of your flight. And so for us, the products we are currently designing mix air traffic control algorithms that help to forecast what will be the state of the sky, what will be the complexity of the sky a given aircraft will meet, so that we can forecast if it will be easy or not to change the trajectory, will it be in the vertical path or the lateral path, so that will be more efficient from a CO2 perspective. And you can clearly imagine that what we are working on could be also applicable to non-CO2 effects, because there will be also trajectory management that would be implied.
Why do you call it green capacity? It's a very specific term, and I think that Michelle Bishop also picked this term because it's something that Thales shaped.
Yeah, that's a term we shaped with the help of the DSNA, which is the French National Authority for Air Traffic Management, with Eurocontrol also. And well, it's kind of an answer of another term we have usually in air traffic management, where we have hotspots. Hotspots are situations where traffic is more complex, which is a bit more difficult to manage. And in fact, we took the inverse term, saying, okay, hotspots are red spots. You see that. It's kind of an alert in terms of safety and complexity. Well, what would be the inverse of red spots? That would be green spots or green slots or green capacity, meaning, okay, there's no safety issue. The complexity of the sky is quite low. We are pretty sure that airline and air traffic controllers, when it's green, could have more time to work together, to collaborate, to get the best trajectories they could get.
All right. And what is your confidence that the projected or anticipated 10% of potential emission reduction, coming from operational improvements, which is always part of this chart, when you basically predict the CO2 emissions up until 2050, 10% is being discussed as the potential coming from better operations. What is your level of confidence that this could be achieved?
For me, it's quite high, but we have to discuss why. Because if we take the European point of view, we know that it's a bit difficult, because we've been working with SESAR and Clean Sky for many years to improve that, and we have a very dense sky. The complexity of our sky is quite high, and so we know that we cannot just use what we have been used to do for years to reach this 10%. And then there's also the worldwide aspect, where we know that many other countries do not have the technological levels we have in Europe. And so just by saying, okay, if we apply recipes that works well in Europe, in many other areas of the world, we are pretty sure that we will go towards this 10%. So with regard to the two aspects I just listed, what happens in Europe and what could happen in other areas. I think in Europe, if we want to reach the 10% or more, we will have to link CO2 and non-CO2 effects. That's the way, to me, where that's the opportunity we have to go towards this 10%. There are still a few percents in terms of CO2 we can get, by shorter trajectories, because we know that it's still possible. There's still a lot of room of improvement in vertical trajectories too. And that's what we work a lot on at Thales right now, because we know that there are various aircraft now that are operated, each aircraft has its own performance. And from an air traffic controller point of view, that's very difficult to know what can or cannot be done by a given aircraft. And so for us, the way we can bring this knowledge into the very technical and critical systems of air traffic controllers to help them on a daily basis to understand and forecast what an aircraft can or cannot do in terms of performance, that would be very important for us to reach this next level. We need to ease the sharing knowledge between airlines and air traffic control so that everybody works with the same level of understanding of what can be done by any aircraft on a given flight. So to me, that's one of the first challenges in Europe. That's this collaboration around a common knowledge of what can be done. Based on that, I'm pretty sure we will get interesting improvement in terms of CO2 emissions. And then we have non-CO2 effects, which are very different depending on the area of the road, depending on the weather conditions you meet. And I'm pretty sure we will discuss this a bit more during the discussion. But for me, that's a very big room of improvement, especially if airlines and air traffic control work together on this topic. So that's for Europe. Worldwide, well, our job is to ease the transmission of European innovation in other areas of the globe. Would it be in Asia, in Australia, and so on? And so that will be very important for us, I think, to reduce CO2 emissions. And once with this kind of role model we can have on non-CO2 emissions in Europe, I'm pretty sure we will be also able to use that for longer flights across the world.
So reaching the 10% emission reduction will be a challenge, especially in Europe, because of the many countries that are involved and the many institutions that will have to collaborate perfectly to make it happen. But then on the plus side, there are many projects, and Europe certainly is a very innovative region to be pushing that. And that leads nicely on to the first project that we wanted to discuss, where you and Thales are involved. And this is the project called CONCERTO. And as always, it is an acronym that stands for the following. I'm helping you here and reading it out. It's the construction of novel certification methods and means of compliance for disruptive technologies. What are the objectives of CONCERTO?
Well, so CONCERTO for us is really the huge project we have to make what I just said before feasible and real. So, as I said, one of the big topics we have is to help the different air navigation service providers and airlines to collaborate on a daily basis. And that's why we built CONCERTO, which is a SESAR project. So it's sponsored by the SESAR joint undertaking. And that's really the perfect project for us to work with many countries so that we ensure that this collaborative way of working to reach the next level of CO2 emissions reduction and the capability to introduce non-CO2 emissions reduction strategies will be feasible. So that's why in CONCERTO we work on two different solutions. The solution number one is mainly developed with Air France, with the DSNA, so the French authorities, and also ENAV, which is the Italian ANSP, so that we can have collaborative ways of optimizing vertically many flights to reduce their CO2 emissions. Because we still see air traffic control constraints applied on a given airspace and not on another one. And from the airline perspective, that's really difficult to know which constraints I should apply or not, and if they are consistent from one country or one airspace to another. And so the idea is to say, okay, can we forecast the complexity of the sky that we will meet in the day or the days to come? Can we see if the constraints that we are used to apply on airspace are still suitable or not, depending on the complexity we have forecasted? And based on that, can we give this information to airlines so that they can plan the best flight they can really plan? Because most of the time, the flight they plan and the flight plan they get from Eurocontrol, the network manager, is not always the best one. What we try to do with this collaboration is to see if we can plan the best flights most of the time, and really to adapt very dynamically to the real complexity of the sky that a given flight will meet. To do that, we really need air traffic controllers' confidence. That's why we want to give them the tools to get this forecast, to anticipate it, and so that they can decide if they give this additional freedom or not to the airline to plan a flight plan which is a bit different than usual. That's the first solution, mainly focused on collaborative reduction of CO2 emissions. And the solution 2, well, its main goal is to introduce the non-CO2 problematic in the operational concept. So the idea, again, and that's what we decided in Thales, is still to develop products, services that will help for the transition of flight operations. So non-CO2 effect can be seen as something a bit disruptive. It has not been the main topic in flight operations management for the past years. And it's something that is sometimes a bit difficult to understand and to plan. Well, our mission in this second solution in CONCERTO is to see how we can ease the introduction of something that is a bit complex in the daily work of dispatchers, pilots, flow managers, and air traffic controllers, because we do not want them to manage the complexity of the science which is behind non-CO2. We want them to get it in their daily operations as something that is very usual to manage. They are used to manage weather conditions. They are used to manage airspace closing. They are used to manage some constraints. Well, why should it be different? And that's the goal of solution 2, is to say, okay, how can we give the information about disproportional non-CO2 effects of a flight for all the stakeholders? And then, as we can see, it's kind of a new constraints to avoid or to minimize with regards to persistent contrails, for example. Our goal is to say, okay, this will define new areas where I do not want to fly or where I want to minimize the time I spend in. Well, these kind of areas do not stop at the borders of a given country. So if you want to have a flight that is well planned, will be efficient in terms of persistent contrails avoidance, it has to be well done between the different countries you will cross and where you will try to avoid these conditions. And so this solution is also a way to make the different countries collaborate so that they take common strategies to avoid big contributors to non-CO2 effects, and so that it will magnify the effects when we manage a given flight. That will be a shame to manage a flight correctly on a given country, and once you cross the border, you go right across what you tried to avoid.
That totally makes sense. And I'm wondering, these are two approaches which in themselves, they sound very promising. And I'm wondering, I mean, it should not be regarded separately, right? So in the long term, they have to come together. So how do you envision these two approaches then playing together in, I don't know, the mid and long term?
Yeah, in fact, for us, that corresponds to the question you asked a few minutes before about green capacity. For us, that's the common point between the two solutions. The first solution introduces green capacity to reduce CO2 emissions, and for us, that's the way we see to play with this new kind of observations, learn how to use it correctly, how to publish it to the different air traffic control authorities, the different airlines, and so that everything gets used to it. Once we will be used to these new strategies with regards to CO2 emissions reduction, well, we want to try to use the same artifacts to reduce non-CO2 emissions, because we think that if we target the right flights that are big contributors, and if we can target these big flights with big contributors in green capacity contexts, well, it will be way easier to manage. That will not have any stress, operational stress, would it be for pilots or air traffic controllers. And so during the transition, we think that's very important to correctly manage what we call the low-hanging fruits. And typically, if we mix non-CO2 effects contributors, a great capacity to detect it, forecast it, and cross it with situations where green capacity will be met, that's for us a great opportunity to start mitigating non-CO2 effects in the near future. Because if we want to reduce non-CO2 effects on all flights, whatever the air traffic conditions, well, we will do that in 15 years or more. So if we want to start it as early as possible, we think that green capacity is a great concept to start playing on non-CO2 effects as soon as possible.
Right. So looking at the second work package, the non-CO2 effects, within the scope of this podcast, maybe you could give like an exact summary of where do we stand there right now and what is the scale actually of this being implemented?
Yeah, so for this second solution in CONCERTO, focused on non-CO2 effects, we started at what we call technology readiness level between 3 and 4, and we have to raise the level to 4 to 3 to 5, and maybe a bit more depending on what we can do with airlines and the traffic control. And our main goal during this project is to end with live simulations with several countries and several airlines to play the different strategies we have already imagined to be able to forecast the flights we want to play on, run optimizers we developed in Thales, but also with the DLR and TU Delft to minimize the effects we are looking at. And based on these forecasts, this capability to run optimization algorithms, well, publish it to airlines and via traffic control in simulation and run it as it would be real flights. The idea is to see how this thing that seems complex from a scientific point of view can be applied really easily by operational stakeholders that should not ask themselves, can I be confident in what the system tells me? So really, we introduce it in the real systems for safety management, but also for capacity management, to see if it changes anything in the way they are used to work. That's really what we want to show. So our main goal, again, is to perform these simulations to ensure that all the end users will be able to adopt this technology, adopt these new constraints about non-CO2 effects really easily with a very low level of additional training and no additional stress. So for us, as Thales, our focus is to focus on this adoption phase, the feasibility of the algorithms in terms of uncertainty, precision of weather forecast, and so on. That's why we work with the DLR, the DWD, and so on. Each contributor has its role. Our role is to be sure that it will be easy to deploy and easy to put in the hands of the operational stakeholders.
You have a background in human-machine interaction, right? So I'm tempted to ask you how you view, live simulations versus actual implementation in the air. Do you think that there will still be a gap because then there might be a different procedure still, even though the simulation may be good, but how do you view the gap then to eventually operationalize it, especially from the point of HMI, so human machine interaction?
Yeah, for sure there is a gap, because in simulation, even if you are very professional, there's not this real concrete additional stress you have when you are really at your place and with a situation that is not planned at all, and well, you have to adapt yourself. So that's why there's a difference, and that's why we want to go a step further in terms of experimentations, but we are still defining it with the different stakeholders with the air traffic control in the different countries, with Eurocontrol, with the airlines, to design the best real experimentations we need. Nevertheless, live simulation is very interesting too, because we can play very, very different situations that might even be difficult to reproduce in the real life, to be sure that it will be resilient to what could happen. And at this stage, as I underlined it, adoption will be key. So if we can push some constraints, if we can put in the hands of operational stakeholders some very difficult scenarios in simulation and show that it works, I think everybody will also be very, very, very confident for the next step in live experimentations. So that's why simulation is very important for us, and that's why also we invested in a very interesting solution, which is our own laboratory here in Toulouse, so that we can host pilots, air traffic controllers, in a specific room where they can really go deep into the solutions we are designing and play as if they were at the office or as if they were in the cockpit. So that's very, very, we have a very representative laboratory here in Toulouse to improve the results we get at the end of live simulations.
And especially when introducing disruptive technologies to the market, simulation is something that you typically do. However, what we've not yet discussed explicitly is what kinds of disruptive technologies are being used. You mentioned, for example, the traffic flow optimizer, in collaboration with the DLR, for example, but what are some of these disruptive technologies?
So the first one, it's about the green capacity. It's the capability we have to hybrid data coming from the air traffic control systems and all the data we can gather from other sources to build a high level of confidence in terms of a forecast of air traffic complexity. So that's the first family of disruptive technologies we are developing. That's this capability to hybrid very various data. Will it be historical one, live ones from the air traffic control systems, from our own systems, so that we have a very high level of confidence in terms of the forecast we provide, and we can also cross that with the weather conditions expected and so on to really see the scenario in which we will evolve. As a first family. The second one is linked to the technologies that will be in the end of air traffic controllers. And for that, we have really focused our efforts on a very specific air traffic controller, which is called the Flow Manager. It's an air traffic controller that works a few hours before operations, and his role is to scan the sky to be sure that what has been planned can be done in a safe manner, to ensure also that you have enough air traffic controllers in the air traffic centers and so on. Today, his main mission is to be sure that everything will be done safely and with punctuality. Well, we introduced the green capacity concept in his environment so that he can also be our human detector of green slots in which it will be easier to perform very ambitious trajectories to reduce CO2 and non-CO2 effects. So there are new algorithms behind that, but what is also innovative is the way we present the information so that it's really understandable, and you can do that in a few minutes, because we do not want to see their job being much more complex than what they used to do. So that's the two main technologies we have that are really, really close to air traffic control. And what we are also working on a lot with scientists is the capability to detect the level of confidence we have in contrails detection or contrails forecast, to be sure that we will activate all the operational stakeholders if and only if the level of confidence is high, because we do not want to spend time, we don't want to lose time on flights that are not, let's say, I will not say not that important, but with a high level of uncertainty. And so we have also this family of technologies we want to put in input of all our operational systems to be able to filter what are the flights we should spend time on and the flights we should live in the classical way of operating it.
Now we've discussed the context, we've laid out the challenges and also what are the disruptive aspects about these. And now I want to loop back to my introduction of this project, which included the terms certification methods and also means of compliance. And just, to round this topic off, what is this being certified for? Or maybe you can just briefly comment on for who will it be certified, or in what context will it be certified, and what are the challenges about the certification? Because that's actually, the main part of the name of this project.
For CONCERTO, as it is stated in the name, it's mainly a challenge of creating the right collaborations between the different stakeholders. In terms of certification, well, we decided to change a bit in the way we are doing it. In Thales, we are used to design, develop, and deploy very critical systems with high level of certification concerns. And for these climate concerns, in fact, we need to improve the way we operate and we perform flight operations for this new and this very important topic. But as we still want to always be very safe, we only provide recommendations or solutions when the situation is safe enough. So that's why we design everything as systems that can be put in parallel of critical systems and not embedded in the critical systems, so that we do not reduce the quality and the level of safety that actual system can manage. So it's always seen as something that is in parallel, optional, and that can be activated when the operational situation is suitable for that. So there are certification concerns, but let's say it's kind of a trick to be able to put that just very close to safety systems, but not into it, so that we do not reduce the level of safety that can be managed in the years to come. I'm pretty sure that all these environmental features and solution will be at the end inside the critical systems, so that we will be able to generalize it on any flight in any situation. But again, for the transition, we think that it should be in parallel, so that we can start playing with it very safely, with a high level of confidence, and little by little managing more flights. And once we'll be very confident, everybody will have adopted it. It will be in the big safe systems, so that it can be used 24/7 on any flight, whatever the context.
Well, safety certainly is paramount in aviation and especially in air traffic management. However, the next project, I think, if I understand it correctly, also deals with this term of green capacity, as we want to speak about the project Provert. And now I don't have, the spelling out of this project. Maybe you can give some background where this name comes from and what this project is about.
Yeah, well, I will not play with all the letters because that's a very French title. But in fact, Provert was the project that was just before CONCERTO. And that was very interesting. So we worked on that between 2020 and 2022. And that was our way to generate many ideas with air traffic control stakeholders and the airlines to see what could be the solutions to be implemented. Because if we get back in time, in 2020, that was very difficult to say how can we manage CO2 emissions reductions because everybody was thinking, okay, we have to generate even better trajectories. So we need mathematicians, we need aerodynamics experts, and we will find incredible optimizers to improve the trajectories. Well, in fact, there were already a lot of publications about what we call perfect flights, that are the flights that will use the minimum of fuel to get from point A to point B. But everybody agrees to say these perfect flights are most of the time not feasible. Okay, so in fact, Provet was based on this observation saying, okay, that would be awesome to perform perfect flights that minimize CO2 and non-CO2 emissions every day, every time, on any flight. But that's just a dream. So what we did in Thales with our partners was to say, okay, we need a very ambitious innovation project to think a bit out of the box and see what would be the room for improvement, what could be invented to get a step further. And that's where we decided to say, okay, maths are very important to reduce emissions, but maybe something that is really collaborative, something that is really based on knowledge that can be shared to most of the stakeholders very easily with no training, etc., would be a great way to get this next step. And so Provet was really a very collaborative project because we did a lot of ideation. Then we produced more than 20 mock-ups and prototypes of different ideas before selecting the 2 or 3 ones that are now in CONCERTO. Because we needed to get very open-minded with the different stakeholders, saying, okay, if we want to get to be ambitious and to be very innovative, we have to learn new things. We have to work together because we are used to work quite separately on these kind of topics. And if we do it together, in a very open-minded way, we will find new things. And that's how green capacity, for example, came out of the way.
Maybe you could briefly describe very tangibly what this solution looks like. So I'm a pilot, I'm sitting in the cockpit. I suppose there is some kind of interface that I have. Now, is it via ATC that I have to use my voice to make a request, or what does it look like actually?
In fact, if everything works great, you might have nothing to do as a pilot. Because what we have also seen is if you want to improve flights, if you can do that in the days or in the hours before the flight, that will be way easier because everybody will be able to anticipate what will happen, to estimate what it will mean to manage it in the sky in comparison to the other flights. If everything is well planned, you might have nothing to do as a pilot, especially if your flight is quite small. We know that you might need updates if you are flying a long-haul flight or something like that. And so the solution is mainly between the dispatcher in the airline and the air traffic control. So about the solution, very concretely, for the pilot, it might be a very small impact because we want to make most of the things before the flight. And so the solution is mainly a way to distribute data between the air traffic control and the dispatchers who are in the airlines and who are in charge of planning and monitoring the flights within the airline. And so if everybody works very collaboratively between the flights, we think that we can use the green capacity concept at its top most of the time before the flight. So from the air traffic control perspective, there will be an HMI for the flow manager. Most of the time, they already use a dedicated HMI to see what will be the situation in the hours to come. What we do is that we provide data that will be added in the existing tools. If they do not have it, we can also provide one so that we can hybrid the analysis of hotspots and the analysis of green capacity so that they have the full view of what will happen in terms of high complexity and low complexity, allowing more efficient flights. If we introduce also non-CO2 effects and hunting contrails contributors, that will be also mixed in the same interface, because we do not want to have many tools for the different concerns. So from the flow manager perspective, you can imagine just one screen displayed on their laptop or on their computer, with the capability to see where it will be hot, where it will be quite easy to collaborate with airlines, and where they should have some awareness of contrails avoidance. That will be mixed in one and only one human-machine interface. For us, that's very important, because that's at this stage where the air traffic control would say, I agree to perform unusual or ambitious trajectory management with the airlines to reduce as more as possible CO2 and non-CO2 emissions. We think that's very important, because if they are not, from the air traffic management side, if they are not convinced that they will be able to manage these different trajectories, that will be very difficult for the airlines to get it. So that's this first part of the solution. And based on that, we consider that information will be shared to all the airlines that are interested in flying a bit differently to reduce CO2 and non-CO2 emissions. They will be able to get this data, mix it with what they have already planned, see if they can compute alternate trajectories, and based on that, send it back to the air traffic control.
You said something very important, and that is ideally you have a lot of information at hand already before takeoff. And so ideally you could, optimize as much as possible before takeoff. And that also includes the prediction, which is very tough, of contrails or even persistent warming contrails. And just something that we wanted to briefly touch upon were the two projects called contrails and Become, which both deal with this. Just as a teaser, there will be a guest, at least one guest, in the future who will deep dive on those projects. However, Thales is involved, and so maybe you could just, on a very high level, outline what these projects are about.
Yes, for sure. So in Thales, we have the luck to have a dedicated organization called Thales Research and Technologies, Thales TRT, where we have scientists and researchers that can work on very ambitious topics for the future. They have a specialization in artificial intelligence for critical systems, because that's what Thales does, whatever the field of application. And in fact, at the same time we launched Green Operations, our researchers had this concern about contrails, because the scientific community was accelerating on this topic, and they said, okay, maybe the way we manage artificial intelligence could be useful for the scientific community and the aeronautics community for this very particular topic, which is contrails forecast and detection. And so for the two studies, which are called Become and Contrails, our role is to work with the DLR, with the CNRS, with metaphysics, and so on, to identify the various artificial intelligence algorithms or methodologies we could use to improve the way we detect contrails in satellite imageries, for example, in the way we can improve the models that are done based on these observations for the scientific or the industrial usage. As Thales, we need to design artificial intelligence algorithms that can be used offline and online, that can embed expertise as well as machine learning. Well, our position is to provide hybrid methodologies wherever we can, so that even if your machine learning is not that good, you can always use also expertise, knowledge that is also embedded in the models, the databases, and so on. So that's really what we want to provide. It's this capability to mix state-of-the-art science and knowledge and what we can learn very fastly based on a lot of data. But what we know and that's also a learning we have from what we do for aeronautics, but also for other businesses. We are in operational contexts where sometimes it's quite difficult to get very precise and accurate data. And so this hybrid approach is a good way to lower the impact of data that might not be of very high precision and so on. So that's why we invest time on that, so that we can be at the rendezvous in terms of technological solutions, even if we do not have always the best data to perform classical AI approaches.
All right, so this was a spoiler for the two projects, which are also very interesting, that will be discussed in the future. But you dropped some very interesting buzzwords here, and you mentioned trustworthy AI. That's a very interesting term. And before we do that, maybe, given the time constraints that we have, I suggest I ask a couple of fire questions, let's say, and maybe you can just give a brief answer. Do you use the term AI, or do you rather say machine learning, ML?
No, we use AI because machine learning is not the answer for everything. And as I said, sometimes a good model based on knowledge that is well structured could give as interesting information as machine learning.
And how do you define AI?
That's the way to automate, deepen analysis, the research for solutions that some human brains could do, but not always, and to provide a high capability to manage very various scenarios, situations, quantity of data, so that we can get the right results. And for us, that's mainly that. That's how we can widen the approach we have of the situations we try to manage.
All right. And what is trustworthy AI then, in contrast to general AI? What makes it trustworthy?
There are some properties that are very important for us as explicability. When the algorithm provides a solution, you have rationals explaining why we have selected it. And also, we explain why we might not give an answer. To me, that's maybe one of the first properties, because, again, in the operational context we have, we need to provide confidence, and explicability is most of the time expected to bring this confidence. The part of the trustworthy part is also the way we validate and verify all the data and knowledge we bring into the models, so that there will be a high level of confidence of what is inside the model and how we checked it. So we also have different frameworks that allow us to perform verification and validation, which sometimes lack in some AI algorithms you could get on an open project.
Yeah, the explainability part is very interesting. The more AI applications you have, and especially the more critical they get, you want to have some kind of explicability. And a very simple example that comes to mind is, for example, when you use object detection or segmentation on images, then you could show some kind of or superimpose a heat map that shows, well, what is the machine learning algorithm actually looking at? Which pixel is it looking at in order to determine that, it detects a certain object. That's a very, very simple example. But for me, that always begs the question, or it's a field of tension, in my opinion, because you want to automate more, and actually you want to have less explications, because having something explained always takes time. So how do you strike that balance between being highly automated and yet being highly explicable or highly reliable?
Yeah, that's very difficult. And in fact, from an industrial point of view, that will also depend on the stakeholder that is implied in the life cycle of the algorithm. Because as an integrator, you might need a very high level of explicability, because you will deploy an algorithm you might not have designed to all your users, and you might get feedbacks and so on, and you will have to be able to manage all the feedbacks you will get, what they understood, what they haven't understood. And so that could be a topic. As an end user, would it be a pilot or an air traffic controller? We might not give all the content of the explicability, because, as you said, from a human factor point of view, if you give too much information, that could lead to uncertainty, to have a lot of doubt, and that's not what we want to provide. That's why that's very important also to really well filter all the recommendation and information that will be provided to pilots and air traffic controllers that do not have time to take a look at all the details. So explicability could be understood differently from a software development perspective, from a software integration and deployment perspective, and from an end user perspective, where you have to be confident in what you will do if you have to take decisions. And so there are different kind of information embedded in explicability depending on the end users. And for sure, that will be a big topic for us, for contrails management, for example, to see what is the right and just level of explicability that we will provide for pilots, flow managers, and air traffic controllers. And what we think is, if we correctly explain the boundaries we put in the detection phases, maybe, that could be enough. I mean, okay, there are conditions that seem to lead to big hit contrails, okay, but since the weather is like this, and since your air traffic complexity is like that, do it or stop it. And that should not be more from an end user perspective. For the rest of the life cycle, we might need to provide more information to be able also to improve the services as long as they live.
So within contrail management, can we give we've discussed contrail management plenty of times in this podcast. So I think that the audience is kind of aware of the value chain or the steps necessary in order to successfully avoid persistent warming contrails and also verify that. And within that value chain, what are the 2 or 3 concrete applications of AI that you see that are promising?
Well, first of all, for the forecast, for sure, because we see that we still need to improve on that. In the accuracy of forecasts that will be taken as input for all the rest of the operation, for sure. I think we will also need AI to compute the alternate trajectories we might want to fly to minimize the effects we try to avoid. As I said before, reducing fuel consumption to reduce CO2 emission or avoiding contrails formation is really important, but it should not be against safety. And so that's a kind of multi-criteria problem, and that's typically the kind of problem we can manage with well-selected methodologies, and AI will be part of it. So to me, there are these 2 challenges. And we also have a huge challenge in the way we manage all the observation data to improve all the chain that will be used by all the stakeholders. And that will generate really a lot of data. And we can try to do it by ourselves manually with humans, but we will need AI to reduce the amount of work our experts will have to do.
Okay, so this was a set of applications where AI can really help in the future to successfully avoid warming contrails or even, non-CO2 effects in aviation. Of course, this needs to be done in a safe manner, right? Given, or let's assume that it's been done safe, it's more like an optimization. Whereas other applications of AI, I'm looking at advanced air mobility here right now, where maybe you want to reduce or remove the pilot entirely from the cockpit. That's something that is super safety critical, right? Are these 2 extreme examples, let's say, regulated in the same way with regards to, implementing AI in that application? Are the requirements for them to be implemented the same?
No, in fact, that will be a bit different, because if I take your example of urban air mobility, you want to ensure the same level of safety without a human in the loop. And so your system should be as safe as 1 or 2 or 3 humans that are used to manage very various situations and all the training they have and all the capability they have to manage the unexpected. And that's a huge challenge we are also working on at Thales for what we call the autonomy challenges. But to me, it's different with what we are currently doing for green operations, because, as you said, we are looking for an improvement. And what we have to show is by introducing this search for improvement, we will not reduce, we will not impact the safety, the level of safety we have right now. So we have to demonstrate we will not impact the great work everybody is doing, but and for the applications where we will do it, we will do, I don't know, we are looking for optimizations and so on, without putting a pilot or an air traffic controller in the loop. At the end, it will be checked and validated by the pilot or the air traffic controller. We will not take the decision instead of the pilot or the controller. So our main job is to be sure that we will not introduce a too high level of complexity, and that it will not reduce the capability of the operators to do a great job. On one side, we have to design a full system for autonomy. On the other side, we have to be careful on the impact we have on a work that is already great.
I promised a rapid fire round here, and I still have 1 or 2 questions to shoot, just because I'm so curious about this, and also because of your background. And that is, you mentioned the simulation facilities that you have with Thales in Toulouse, for example. And I suppose when you simulate air traffic management, it's very comparable to the concept of a remote tower, by definition, right? Because everything has to be digital. So I'm an air traffic controller. I'm looking out of the digital window, let's say. And something I've seen that I found very interesting in the past was you augment the basically digital view out of the window by, for example, object detection or by segmentation. So in other words, you look outside the window and the runway would be colored in a certain way, or the vehicles moving around have a rectangle around them, you know? And of course, for the aircraft, you know which aircraft these are from other data sources, but maybe there is a very big bird, you know, you don't have the ADS-B data, but yet the object detection could visualize this, you know. I think this is a very good example of where AI could facilitate, at least, you know, or help the air traffic controllers. Are there any other interesting applications of AI, you know, that are directly interacting with the human in a tower that you see?
Well, there are many projects on that which are not directly related to what we do on green operations, but that could be useful, because any technology that would give the opportunity to an air traffic controller or a pilot to spend more time taking a look at the climate concerns is, for me, an interesting technology to take a look at. And so, from an air traffic control point of view, there are a lot of work made on the different what's called multimodality, so the capability to control the interfaces, for sure, with the devices we are used to, but also with voice recognition or detection of patterns and commands in what controllers say, to extract words and to be able to, from this extraction, give the words or the elements of context to other stakeholders, because we know that we are coming from a very voice-centered way of managing operations between pilot and controllers. There is no text messages that have been implemented, but you can see that if we were capable to extract contexts, orders, confirmations, and important information from all the things that are said, that would be very helpful for pilots and controllers to reduce the level of uncertainty. And Yeah, so that's a kind of technology I've seen and people are working on. As you said, there's also AI for detection, but it could be detection of patterns, for example, patterns of trajectories that could lead to a conflict in 5, 10, or 20 minutes, so that we can reduce the number of dangerous situations air traffic controllers have to manage. That's typically great technology to reduce the workload of air traffic and stress of air traffic controllers. And again, all the technologies that will allow that will reduce the amount of work they will have to perform in a, let's say, last minute way. And if they have less time to spend on that, they will have more time to take a look at a wider sky and spend more time with pilots and so on to improve operations. So yes, there are a lot of applications of AI to ease and detect safety concerns so that they can have more time to do other very interesting things to improve the way we fly.
Now, to round it off, we can now proceed to this tradition of passing on the question. And our next guest is Alain Siebert, the CTO of SESAR. So you could help me prepare the questions now, at least with one question that comes to mind.
Yeah, my question would be, as we are working on SESAR right now, how can we accelerate the innovations we are developing in SESAR so that at least part of it could be used in a very near future? Because we see that we might lead to a quite complex, ambitious technology that might need still some years of work to be able to implement it. But I'm pretty sure there are small parts of our technologies that could be used faster. And how can we work with SESAR to accelerate it, to deploy it at scale without waiting too long? Because the challenge we have for the climate needs to start things right now, even if it's on 0.1% of the traffic. That's still an improvement in terms of fighting aviation's emissions. So that's my question. How can we accelerate the deployment of parts of the technologies we are working on so that we accelerate the transition toward lower emissions?
That's a great question. I appreciate it. And this has been a very extended session, but I said right from the start that I'm curious about sustainable aviation and AI. And I think now we're getting closer to, meeting that promise. And so you were a brilliant guest, Chris. Thanks so much for being part of this.
Thanks a lot. That was a very interesting discussion. And I'm glad to discuss all these topics because we can see that from a technological point of view, there are links between different families of technologies, and that's by working in parallel on all of that we will reach the ambitions we have. It's very ambitious to try to reduce the emissions of 10%, but I think that's a challenge which is worth it.
Well, ambitious is the perfect word to round this off. So speak soon, Chris, hopefully in Toulouse, and thanks again.
You're welcome.
Bye-bye.
Bye.